Hey guys, welcome to 9.3. We're going to be working with sequences. Most of this chapter is going to be pretty straightforward. I think the word sequence is pretty self-explanatory, right? It's a progression of numbers. And we're looking at patterns and making sure we know how to define them. We'll be working with finite sequences and infinite sequences. Again, self-explanatory. We will be referring to terms as kth terms. So if you have a sub, let's say a little, instead of the k there, you'll have a 99. That would say a sub 99 will be the 99th term, right? They're going to be natural numbers for k because they're basically counting numbers, right? 1 denoting the first term and 1000 denoting the 1000th term, right? So a sub 1, a sub 2, a sub 3 would be the first 3 terms. So doing example 1, really simple. All we have to do. Oh, and actually before we do example 1, here's some examples of a sequence, right? You have one that's just defined right there. That's a finite sequence. 2, 4, 8, 16, 32. That could be defined explicitly as 2 to the k. For k being whichever kth term you are at. So the first term would be 2 to the first, and that's why it would be 2. 2 to the second would be the fourth term, right? So the k denotes, again, which term, the kth term that you're looking at. Similarly here, I can define it like this, where 1 over k is the definition of the each kth term, and it's saying k would be for 1 to infinity. So this set notation here would represent 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over, and it would go on to k approaching infinity. So that's an infinite sequence there. And of course, this is just a set of infinite terms, right? And here we don't have what defines each term, but this represents those terms, a sub 1 all the way up to a sub k of, and the ellipsis here would indicate that it is an infinite sequence. So again, going to example 1, this is a very straightforward one. So I want the first 6 terms in the 100th term, and this sequence is defined explicitly right over here, right? So explicit. So this is basically the rule for getting which term you want. So if I want the first term, it'd be a sub 1, right? That 1 means it's the first term, and then it's just 1 squared minus 1, well, not 0. Here's the second term, a sub 2. It's defined by 2 squared minus 1. It's 3. A sub 3 would be 3 squared minus 1. That's 8. And you get the idea. So a sub 4 would be 16 minus 1 is 15. A sub 5 would be 24. And a sub 6 would be 36 minus 1, which is just 35. All right. If we want the 100th term, a sub 100, that would just be 100 squared minus 1, which is 10,000 minus 1. So that's just 9,999. And that's an explicit sequence. That's a sequence that's... actually, we don't even know if it's finite or infinite because we don't know if what the set looks like, right? But we do know the explicit definition. So that's what we just did here, right? That's the explicit definition of a sub k.